Let's start with basics of vectors. Things which you have already learned, it's more like a recap. Now, whenever we talk about a vector, vector is a quantity which has both magnitude as well as direction, correct? Now, let's understand what is a vector and how do we represent a vector. For this, see, we have x and y axis. Now, in this x and y axis, you have the origin as O. Now, let's assume that we have some point. Assume some point here. Say we have a point A. Fair enough. Now, for this particular point A, let's assume that we are going to join from origin to that particular point A. Fine. So, if you are going to join the origin, so from this is one point and this is one more point. So, here we are going to join from here to here. Then we write an arrow mark. Now, here we write that OA is a vector. Because one, it has a magnitude. Magnitude is nothing but the distance of OA. Then the direction. Direction is from O to A. Correct? This basically is what we call as a vector. So in general, suppose if OA is represented as vector A. Assume vector A. Then we represent that vector A is equal to, it has both magnitude, which is the modulus, as well as the direction, correct? So vector A is equal to modulus of vector A. What we mean by modulus is the magnitude. So magnitude and the direction is given by A cap. So here this is the vector. This is a vector. This gives us the magnitude and this gives the direction. So every vector, doesn't matter what type of vector you have, every vector has both magnitude as well as direction. Okay. Now magnitude, see, whenever we talk about magnitude is basically length, correct? Can length be negative? No, obviously not. That's why modulus of vector A is always, this value is always greater than 0. This can never be a negative value. It can be equal to 0 or it can be greater than 0. This is possible. Okay. That means direction can be negative. What we mean by direction as negative? Here the concept of left, right, up, down, all these things will come. Now conventionally, anything to the right of origin is positive. Anything above origin is positive. Correct? And anything to the left and below the origin is negative. So conventionally speaking, direction can be regarded as positive and negative, whereas magnitude can never be regarded as negative. Magnitude can be 0 or it will be greater than 0. This is the case for any type of a vector. Now, you understood what is a vector. Anything which has magnitude and anything which has a direction is basically vector. Now, we can discuss this with a lot of practical examples. For example, let's say people are playing football. FIFA, for example, people are playing football. If someone kicks a ball, it has a magnitude as well as direction. So it basically is a vector. Now, we are learning vectors in mathematics, whereas last year you guys learned this in physics. Of course, application of vectors is physics, basically speaking. Whereas the concept of vectors started out in math. Because whenever we talk about a point in space, or whenever we talk about a point on a plane, always where the point is situated and what is the distance of the point. These two are very, very important, correct? Now, where the point is situated, this is where direction comes into play. And what is the distance? That is basically the magnitude, or what we call as the modulus. This is how the concept of vector is, this is how we use vectors in math. Because in math, Whenever we talk about a point in space, remember we are talking about 3D, x, y, z, okay? Or you can take x, y also in a plane. Where the point is situated, that is very, very important because we have a subject called as topology, where position and how the plane and space is there, that particular subject is what we call as topology. Now, in this particular case, especially in vectors, the positioning of the point plays a very important part. Okay, if you have to know the position, of course, the magnitude is also quite important. Now, since you have understood the basics of what is a vector and why do we learn vectors in math, let's talk about basic types of vectors. There are different types of vectors. Let's look into those type of vectors now. Vector is called position vector. Okay, it's a position vector. Now, position vector talks about where the point is situated, the position of that particular point. For example, see, assume that you have the y and x axis, assume, and we have a point here which is A. A is given by x comma y, assume. Now here what we'll do, from O to A, we write a vector like this. So this OA vector is what we call as position vector. Okay, so this is basically position vector. Now mod of OA, this becomes root of x square plus y square, because we are looking at 2D, correct? So we are looking at 3 dimension. Then same, imagine instead of xy, say you had xy and z, assume. Then OA is going to become a root of x square plus y square plus z square. This is in 3D geometry. Clear? So this is the first type of vector, position, where the vector is situated, where the point is situated. This is basically position vector. Okay. The second type of vector is a zero vector. Now, zero vector is that type of vector where the magnitude is zero, but it has a direction. Now, this might be a little confusing to understand. How can something has zero magnitude, but it has a direction? Now, simple example, practical example, I'll tell you, okay, turn towards north. Okay, turn towards north, but don't move. Just stay there as it is. You have a direction, but you don't have any magnitude. This basically is a zero vector. That means a zero vector is that vector where the magnitude is zero, but it has a direction. Magnitude is zero. So we generally represent it as zero vector like this. Okay, this is a zero vector. Clear? Now let's look into the next type. Vector is a unit vector. Now unit vector is a very, very important type of vector because we are going to use this pretty much everywhere. Now unit vector is that vector whose magnitude is 1 unit, 1 in that particular direction, whatever the direction it might be. Okay, in the sense, suppose, let's say we'll consider the xyz plane. Okay, this is 0, say this is x, say this is y, say this is z. We have the xyz, it's a space, correct? So in this particular space, suppose let's say an object or something which moves along the x-axis by just 1 unit. You know, x-axis is number line 0, 1, 2, 3, 4. Say from 0 you move to 1. That's all, 0 to 1. So assume that this is 1. Okay. Say you're moving from 0 to 1 along the x-axis, right? So in this case, this vector, let's call this point as A. So OA becomes a unit vector. So vector OA is equal to mod of OA into OA cap, correct? This value is 1, and since we are going along the x-axis, we represent it as I cap. always x-axis is represented with the help of I. So this becomes vector OA becomes I cap. Clear? X-axis is always I cap. So we can write here x-axis is I cap. Okay, I cap. Or you can just say I hat, anything. Now, second one, let's say you're going to move along the y-axis. Here, again, 1. This is B. So, same way OB vector becomes J cap. So, that means along the y-axis, it is J cap. Okay. Now, let's say the next one, you're moving along the z-axis. See, like this. Say you move to point C. So, OC vector is going to be K cap. That means along the z-axis, it is K cap. I, J, K. You guys already know this one, but still, along the x-axis is I, along the y-axis is J, and along the z-axis is K. Clear? So, these are what we call as unit vectors. So, unit vectors has a magnitude of 1, but it moves along the particular direction of vector. But specifically for x-axis and y-axis and z-axis, we have a name for it, which is ijk. Clear? So these are what we call as unit vectors. Co-initial vectors. Guys, if you look at the name, it tells you co-initial. They start from the same point. Because whenever we talk about a vector, assume that this is a vector O, A. Starting point is O, terminating point is A, correct? Or terminal point is A. So co-initial in the sense what? Two vectors will start from the same point. See, it's like this. So you can say that OA and OB. These two are co-initial vectors because both of them are starting from the same point O. Fair enough? These are co-initial. Same way, we have co-terminal vectors. Co-terminal. What does that mean? Both of them will end at the same point. Correct. Suppose say you have one vector like this. So say OA and say you have another vector which ends here only. Say this is B. BA. So OA and BA. These two are co-terminal vectors. They end at the same point A. Correct. These are the another two types of vectors. It is collinear vectors. Collinear vectors. See, when we talk about collinear vectors, assume that there is a vector here, OA. Say there is one more vector which starts like this. This is AB. See this here, OA and AB. These two are collinear. They are on the same line. Collinear. They are on the same line. They are called as collinear vectors. Clear? The next type of vector, they are equal vectors. Now, equal vectors are quite important because we use these equal vectors in a lot of derivations, especially in addition and subtraction. That's why. Now, suppose say you have vector A. Let's assume this is A. This is OA. And some other is here. Say this is BC, which is vector B. Now, here OA and BC, these two are equal vectors because one, they have the same direction. Two, they have the same magnitude. Only then they are called as equal vectors. Okay, they are equal vectors if they are of the same direction. Two, they are of the same magnitude. Then they are called as equal vectors. Clear? Let's look into the next one. It's very, very important. This is negative of a vector. See, whenever we talk about negative of a vector, suppose say that you have a vector OA like this. Say this is vector A. Now what we do? We take this particular vector, we negate, in the sense we change the direction by 180 degree. So we do the same thing here, but this way. So this vector, suppose let's say this is BC, this becomes negative of vector A. In the sense OA is equal to minus BC. That means you have magnitude is the same, but direction is going to change. When I say change, what do you mean by the change? 180-degree shift. That is basically negative of a vector. Clear? So these are the types of vectors. So in the next video, we'll look into different properties of vectors. You learned the types of vectors. Next, we'll look into the algebraic properties and algebraic operations on vectors.